Alright, so this video is going to be part 8 of our convergence diverge problems with series. So we want to prove if this series right here is absolutely convergent, conditionally convergent, or divergent, and our series is the sum from n equals 1 to infinity of negative 8 to the n over n times 10 to the n plus 1. Okay, so first start off with that test for divergence. If you take the limit as n approaches infinity of this, you're going to see that you end up with 0, okay? And that's kind of, it's a little bit difficult to see at first. I mean, if you kind of think about it a little bit, you see that you just kind of end up with this negative business that doesn't really matter with the limit. You're going to have an 8 to the n here, but here you have a 10 to the n plus 1 times an n, so it's going to equal 0. Honestly, with something like this, I wouldn't even waste your time with tests for divergence, but just for the sake of going through our checklist here, I figured I would include it. Now, the integral test, no. The comparison test, not even. Limit comparison test, nope. And alternating series test, yeah, you could, I guess. I mean, but maybe the ratio test would be a little bit nicer here. So I'm going to actually skip over this and just go right to ratio. Okay? You kind of see that we have all these terms that look like they'll look really nice with the ratio test. Okay, you have like if you see an n or a negative to the nth power, something like that, or a number to an n power. If you see all that stuff all combined and all mashed together, you're definitely thinking ratio test. Okay, so that's why we're just going to go to ratio test here. Now, ratio test is telling us that we need to take the limit as n approaches infinity of a sub n plus 1 over a sub n. And we need to see what that product of the limit is in comparison to 1, if it's less than 1, greater than 1, or equal to 1. So, yeah, limit as n approaches infinity of a sub n plus 1. What's that going to end up giving us here? Well, we get the limit n approaches infinity. A sub n plus 1 is going to be negative 8 to the n plus 1 power over, this will be n plus 1 times 10 to the, well, now this will be n plus 2. That's going to be over, well, that will be over negative 8 to the n over a n to the n times 10 to the n plus 1. All right, so now this obviously looks like a gigantic mess, so we're going to fix this. The limit as n approaches infinity of, let's get rid of these negative signs by using this absolute value, so we end up with just a, well, this will be a 8 to the n plus 1. This will be over 8 to the n. That'll be our first term there. Now we also have a, this will be an n going to the top here, so we have an n over n plus 1. And we have a 10 to the n plus 1, which will go to the top, so that'll be a 10 to the n plus 1 over 10 to the n plus 2. Alright, and remember our limit properties here, we can do each little piece separately here, okay? So that'll help us a little bit here. Now, we get 8 to the n plus 1 over 8 to the n. Now, that's just going to be 8, right? You're left with an 8 to the first power. So we get that this is going to be equal to 8. Now, n over n plus 1, of course, we take the limit as n approaches infinity of that. That will equal 1. And then we have 10 to the n plus 1 over 10 to the n plus 2, okay? Now, if we do our subtraction here, n plus 1 minus n plus 2 in parentheses, you're going to get a 10 to the negative 1. So this will be multiplied by a 1/10 power. Or sorry, a 1 over 10. Jeez. So that's going to be equal to 8 over 10. 8 over 10 is less than 1. So this is going to be absolutely convergent by the ratio test. And we have our next series up on the board here, the sum from n equals 1 to infinity of negative 4 to the n over n squared. Now this is another one of those problems where it's not going to be a ratio or root problem, so what we're going to have to do is see if this alone is convergent or divergent, and if it's convergent, we need to see if this this with an absolute value around it is going to be convergent or divergent, and that will tell us if it's absolute or conditional. So first we need to see if this is convergent or divergent, like I said, and to do that, well, we can use the test for divergence here. That's just going to give us 0. So that's not going to tell us anything. Integral test, no, we have that negative there. Comparison, no. Limit comparison, no. Alternating series, that seems like a good idea. Okay, so this 4 won't change anything, so I'm going to make the b sub n here. That's just going to be 1 over n squared for us. Alright, now this b sub n, is this decreasing? Well, if we want to figure out if this is decreasing, we need to look at that next term in the series, which is going to be 1 over n plus 1 quantity squared. Okay, of course, this is a larger denominator than this, which means that this whole fraction is smaller, and that means that 1 over n squared is going to be larger than 1 over n plus 1 quantity squared. Okay, so now we need to see if the limit as n approaches infinity of 1 over n squared equals 0. Of course, we know it does. So not only is it decreasing, but the limit also equals 0. So we know that that is convergent by the alternating series test. And since this is convergent, we need to take the absolute value of this series to see if this is going to be absolutely convergent or conditionally convergent. So let's write our series over here and put absolute value signs down. Okay, this is just saying that we have the sum from n equals 1 to infinity of, well, the absolute value. That's just going to be 4 to the n over n squared. So now with this series, we need to see if this is convergent or divergent. And if you write out your little checklist here, DICLAR, okay, start off with that test for divergence. And actually, if we take that limit as n approaches infinity here, well, 4 to the n over n squared, it's kind of rather obvious what is going to end up happening here, right? I mean, 4 to the n, you plug in a 5 for n, and you end up with a 25 on the bottom, but a huge number on the top, and that's just going to stay consistent as the limit as n approaches infinity. Okay, as n approaches infinity, I mean, that gap just is going to get wider and wider and wider between the two. So this is going to equal infinity, and that means that this diverges by the test for divergence. Okay, and since we have a converging, okay, and a diverging, that means that this is going to be conditionally convergent. And that is going to be it for this video. So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for sequences and series and the next video in the series. Lastly, if these videos are really helping you and you would like to consider supporting me, I have my Patreon linked in the description down below, along with some other pretty cool links that you should definitely check out. See you soon.